Hi everyone, welcome back to Miss Reva's class. Here, I'll answer the exercise of math for grade 3. Let's start from number 1. Look at this picture. There are how many blocks? Let's do the fastest way. If you see the cube, one cube, it has 1000 blocks. If it is 1, 2, 3, 4 cubes, so it has 4000 blocks. And let's see the flats. In one flat, it has 100 blocks. So if it is two flats, so it would be 200 blocks. And then next we have 3 roads. In one road, it has 10 blocks because there are 3 roads, so it has 30 blocks. And the last one, we have 8 blocks. So there are 4,238 blocks. How do you write it in words? It is 4,000 without S, comma, 200 without S again, and 30. Don't forget to give strip sign 38. Between tens and ones, we need to give this sign. For number B, C, and D, I already attached the answer in the answer sheet. Yeah. So for number 2, complete the number patterns. I'll start from C and F. You can see the C, 785, and then 885. It go bigger. Yes, it's gonna be plus. But plus what? Look at here. The ones is same, the tens is same, but the hundred is different. The hundred here we have seven, and the hundred here we have 8. How can 7 become 8? It is plus 1. Because it is at hundreds, the difference, so we need to plus by 100. So the next gonna be plus 100. It's gonna be 985 plus 100 again. It's gonna be 1085. To that, for F to F. We have 5,411 and then 5,311 and then 5,211. The number is getting decreased. So it's gonna be minus. But let's take a look. Which number is different? At ones, we have 1, 1, 1, same. And then for the tens, we have 1, 1, 1 also, same number again. And then the hundreds, we have 4, 3, 2. Okay, so it's different. Let's see the thousand. The thousand is 555, same. So we already find out that the hundreds is different. How can 4 become 3? We need to subtract by 1. Because it is in hundreds, so we need to subtract by 100. Next, 3 became 2, subtract by 100 again. Next, we need to subtract by 100 again. It became 5,111. After that, we need to subtract by 100 again. It is 5,011. For number 3, I'll answer A and B. For A, for more than 7 is what? Let's say I have 3 pens. Yeah. And then Dora has 2 pens. Dora gave me all of her pens. So my pens is getting more. Now, my pens is became 3 plus 2. It became 5. So, every time we have more, it means it's supposed to be plus. So, at first we have 7. Getting 4 more, it became 11. For number 3b, 2 less than 8 is, let's say I have 6 pens, and then I give Dora 2. Yeah, I give Dora 2. So how many pens that I have left? It is 4. 1, 2, 3, 4. This is what I have now. How can I get 4? Because at first I have 6 and then I give Dora 2, so my pens is getting less. So when we have getting less, it means to be minus, to be subtracted. So 2 less than 8 is, at first we have 8 and then it getting 2, it getting less by 2, it gonna be 6. It would be 6 left. And then number 4, I'll answer the third box. At first we have 6,541. It is thousands place, this is hundreds place, this is tens place, this is ones place. Okay. Now, it is plus 789. 7 is in hundreds. 8 is in tens. 9 is at ones. After that, we need to plus them. I need to change the color of this. Okay, so what's the result? Let's do from the ones first. At ones, we have 1 and 9 plus. So 1 plus 9 is 10. How can we write 10? 10 is consisted of 0 as ones, the 1 as tens. So let's put 0 at ones, and then the 1 we put at tens, at up here. There. And then after we do ones, let's do tens. 1 plus 4 is 5. 5 plus 8 is 13. How can we write 13? 13 is like this. Because it means 13 in tens is 130. Yeah. The 0 is once, is at once. Actually, it doesn't have any effect. At once doesn't change. Yeah. So let's just concern to 3 at tens and then 1 at hundreds. Let's put 3 at the tens and then 1 at hundreds. Let's do the hundreds. 1 plus 5 is 6. 6 plus 7 is 13. Let's see the 13 again. 13 here, it means that 100 plus 500 plus 700 is 1,300. 0 is at ones. 0 here is at tens. It doesn't give any effect for these ones and tens. So let's see by the 3 here. The 3 here is at hundreds. We put 3 at hundreds, and then let's put 1 here at thousands. Let's put 1 at the top of 6. So 1 plus 6 in thousands is 7. So this is the answer. The subtraction. It's same like the addition. Let's write the thousand, hundreds, tens, and ones. If you can do this directly, just do this. Just do that directly, okay? Without writing this, the place value, it's okay. And then we have the first number is 8,540. The second number is 3,295. 3,000 at 1,200 at hundreds. 90 is at tens. 5 is at ones. We need to minus it. Let's take a look. 0 minus 5. It cannot. If we have nothing, and then we want to give people 5, or we want to remove by 5, it cannot because we have nothing at first. So, how can we do it? We need tens. We have 4 tens. It means 40. We give 10 to ones. It became tens like this. Let's do the fastest way. Let's just put 1 in front of the number of ones here. And the tens is became 30, which is 3 at tens. The value of 3 here is 30. Let's subtract the ones. The ones we have is 10. And then 10 minus 5 is 5. Yeah. And then let's take a look at tens. We have tens 3. If we have 3 and then we want to remove 9, it cannot because we only have 3. So we need to get more 3 in tens by getting it from hundreds. We have 500s here. Let's give 100 to 10. 100 is 10 of tens. Yeah, so let's just put 1 in here. 10 plus 3 is 13 tenths. So the hundreds is became 4. So how is it? Let's do the tens. 13 minus 9 is 4. Okay, so let's do the hundreds. We have the hundreds here is 4 minus 2. It is 2. And then the thousand, we have 8 minus 3. It is 5. So this is the answer. And the multiplication here we have 2012. Actually, it is same, yeah. We need to concern at the place value. It is thousand, hundreds, tens, and ones. Times by 8. 8 is ones. So let's put 8 at ones. Let's times. We need to times the ones and ones first. 8 times 2 is 16. How can we write 16? Let's write 6 at ones, 1 at tens. Put at tens here. And then the second one, we need to times 8 and 1. 8 times 1 is 8. Don't forget we have 1 above. It became 9. And then 8 times 0 is 0. And the last we have 8 times 2 is 16. So this is the answer. And the last one of this number is 95 divided by 5. Let me erase this first. So 95 divided by 5. To do this division, let's just do by the long division to make it faster. This is the division sign for long division, and then the dividend is 95. We put 95 as the first number here, we put inside, divided by 5, which is it is divisor. We put 5 outside. How can we think here? It means that 5 times what is 95? That's right here. 5 times what is 95? So we need to find out one by one. Yeah. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15, and so on. It would take longer time. So let's just take one number, start from this. 5 times what is 9? 5 times what is 9? Look. No one. So if there is no, we need to look at 5 times what is close to 9, but it is less than 9. So it is 5 times 1. 5 times 1 is less than 9. So let's write here 5 times 1 is 5. Yeah, 5 times 1 is less than 9. So 5 times 1 is 5, and then we subtract it. 9 minus 5 is 4. And then let's put the 5 down, so it is 45. Let's do it again. 5 times what is 45? After you write down the multiplication of 5, you will find out that 5 times 9 is 5. So let's write 5 times 9 is 45. And then we need to subtract it again, it is 0. So the 0 here is as the remainder. The 19 here is as the quotient. Quotient here means the result. So 95 divided by 5 is 19. And then next, number 5. A and B is the... Actually, there are 3 properties of mathematical operations. The first, it is the... What is it? Associative, distributive, and then... Wait, I forget. Yeah, commutative. Commutative property. That is for number 5, A and B. C and D is the associative property. And then the E and F is the distributive. So for 5A, 12 times 35 is same as 35 times 12. Because both will give the same answer, and 11 plus 34, sorry, 11 plus bracket 34 plus 70 bracket. The bracket means we need to do this first. And then the result will plus with 11. This also give the same answer if we do 11 plus 34 first. So 11 plus 34, we can do this first, and then we can plus with 70. It will give the same result. For E, Look, 4 plus 3 bracket, we bracket them and then times 9. It means that we can do inside the bracket first. 4 plus 3 is 7 times 9 is 63. It is also same if we do 4 plus 9 first. 4 plus 9 first. Or as the fastest way, we can fill the number like this. Because it is times 9, we will write times 9. It is times 9. Because it is plus, we put plus here. And then the last, we can put 4 at here, 3 at here. That's so 4 times 9 is 36, plus 3 times 9 is 27. It will give the same answer as this, which is it is 63. And then number 6, Dora has 1,453 marbles. Diego has 3,058 marbles. Help them to put those numbers in the place value table. So we need to draw the place value table. Let's do from the thousands, and then hundreds, and then tens, and then ones. And then let's put Dora's number here. She has 1,453 marbles. Meanwhile, Diego has 3,058 marbles. We need to put it to the place value one by one. Dora has 1,453, so we can put 1 here at thousands, 4 at hundreds, 5 at tens, 3 at ones. And then next for Diego, we can put 3 at thousands, 0 at hundreds, 5 at tens, 8 at ones. Explain why Diego has more marbles than Dora according to the place value table. To compare something, we need to see by the biggest place value. The biggest place value here, we have thousands. If we see the number here, the Diego has 3,000, meanwhile Dora has 1,000. So the digits, oh, let me just type it. So it is the digit in thousands belonging to Diego is 3. It is bigger or greater than Dora's digit in thousands, which is 1. It is already correct, or if you wanna give additional explanation at front to compare the numbers, we need to look at the greatest from the greatest place value. The greatest place value above is thousands place. Okay, yeah, that's the answer. We can put it here. All right. And then number 7, Harry donated 1,450 pieces of donuts to a charity. Nobita donated 385 more pieces. of donuts than Harry. So, at first, we have Harry donated 1,450 pieces. Let's draw the bar model here. It is 1,450. Next, we have Nobita, which is Nobita donated more than Harry. So we need to draw bar bigger than Harry. We need to draw longer than Harry. Look, from the first start. If we start from here, so we need to draw the Nobita, also start from here. Yeah. Meanwhile, we know that the Harry's bar ends at here, which is it is same as this, a Nobita bar. So you can take a look at this. If the bar belonging to Harry, we move to Nobita, look. So this area is 1,450. Yeah. So we can write it as 1,450. From this to this. Yeah. And then what is the number for this bar? Nobita donated 385 more, so we can put it in here. 385 more. So how many donuts did Nobita donate? So Nobita donate 1,450 plus 385. Let's do long division. Long addition, I mean. 1,450 plus 385. Plus 0 plus 5 is 5. 5 plus 8 is 13. Put 3 here and then 1 up. 1 plus 4 is 5 and then plus 3 is 8. And then 1 just go down. So it is 1,835. Don't forget to put the number at the conclusion here. So Nobita donated 1,835 donuts to the charity. And then the next question is, how many donuts did they donate altogether? We know that Hari have 1,450. Nobita have 1,835. So if we combine them, their bar altogether, it's gonna be like this. This bar is belong to Hari, 1,450, and then the next bar is belong to, let's make the different color for Nobita bar. Let's draw it as red. The Nobita bar is in here. Yeah. Nobita bar is 1,835. So we need to plus them. 1,450 plus 1,835 is, why we plus them? Because when we sum or we combine their donation all together, it would get bigger. Yeah, as you can see here, the bar is getting bigger. So we plus them. Getting more, we plus them. So 1,450 plus 1,835 is 0 plus 5 is 5, 5 plus 3 is 8, 4 plus 8 is 12. We can write 2 here and put 1 up, and then 1 plus 1 plus 1 is 3. So it is 3,285. Don't forget to write the conclusion here. So they donated 3,285 donuts altogether to the charity. For number 8, Hannah bought 7,500 grams of pears and apples in the market. She bought 3,275 grams of pears. So how many grams of apples did she buy? So let's draw. There are pears and apples. Pears, how many pears? 3,275. Apples, we don't know. Is the bar gonna be longer or shorter than pears? We don't know. And then when we combine them all together, it's gonna be 7,500 grams. So here we have pears 3,275, and then we don't know the apples, but all together from here to here is 7,500. Yeah. So if we put it down, the yellow bar is gonna be like this. It is 7,500. So the logic is 3,275. We need to plus by what? So it can be 7,500. Yeah. So 3,275 plus what? Is 7,500. It means we can subtract it. 7,000. We can write this. We can write like this. We can write 7,500 minus 3,275. 7,500 minus 3,275. Minus them. 0 minus 5 cannot. So let's see by the tens. Tens is cannot also to be broken. And then let's see the hundreds. The hundred has 5. Let's break this. Became 4. The tens became 10. Yeah. And then we can break the 10 here. The tens is became 9. And then the ones became 10. So 10 minus 5 is 5. And then 9 minus 7 is 2. 4 minus 2 is 2. 7 minus 3 is 4. So it is 4,225. So Hannah bought 4,225 grams of apples. So the bar for apples is supposed to be longer. 4,225. There. Okay. So number 9. Answer the questions in the boxes provided. Continue the drawing to expand the meaning of 5 times 7. 5 times 7 means there are 5 groups of 7. As you can see here, it's already one group. So we need to draw another 4 group. It is 1 group, 2 group, 3 group, 4 group, 5 groups. It contains 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so there are 5 groups. It is the first group, the second group, the third group, the fourth group. This is the 5th group of 7. Read the multiplication sentence. The sentence is 5 times 7 is 5 groups of 7. The mathematical expression is 5 groups of 7 is there are 5 groups of 7. So it is 7 plus the second group contains 7. The third group contains 7 plus the fourth group contains 7. The fifth group contains 7. It is same as there are 5 times of 7, which is, it is 35. That's it. And then number 10. SpongeBob has 23 apples. Let's draw it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And then she shared it with Squidward. Let's draw Squidward, Patrick, Sandy, and then Mr. Crab. Okay. Prove that each Squidward, Patrick, and Sandy, and Mr. Crab got 5 apples. Let's prove it. So, the apple here, we give to the Patrick first. Let's give the name here. It is, Squidward first, yeah. This is Squidward, Patrick, Sandy, Mr. Crab. So the first apple we give to Squidward. Second, we give 1 to Patrick. Third, we give to Sandy. Fourth, we can give it to Mr. Crab. So each got 1 apples. So at one time, we share through them. So the apple here is getting 4 less. Yeah. So let's just remove 4. 1, 2, 3, 4. We give to 1, 2, 3, 4. And then every time we give to them, it's 4 less apples from here. 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. It is 1, 2, 3, 4. So let's see. Squidward has 5 apples, Patrick has 5 apples, Sandy has 5 apples, Mr. Crab has 5 apples. So this already proved. But is there any remainder? Yes. The remainder is 3. This is the remainder. The remainder belongs to SpongeBob. And the 5 here is the quotient. Quotient here is 5. It means that each of them, each Squidward, Patrick, Sandy, and Mr. Crab got 5 apples. That's it, yeah. And then number 11, Tessa goes shopping at the market once a week. She always buys 1,500 grams of mangoes. If a month is 4 weeks, how many grams of mangoes does she buy in a month? Okay, so Tessa goes shopping at the market once a week. She always buys 1,500 grams of mangoes. Yeah. Every time she go shopping. If a month is 4 weeks, so there are 4 weeks. 1 week, 2 week, 3 week, 4 week. In 1 week, she always buys 1,500. So each week it is, in this week, by 1,500. The third week, this is the first week, yeah. It is the second week, it is the third week. This 1,500 grams mangoes. It is the fourth week, 1,500 grams of mangoes as well. So how many grams of mangoes does she buy in a month? In a month is 4 weeks, so it is a month. How can we do it? There are 4 groups of 1,500. It means that 4 times 1,500. Also, we can write it also as, it is same like 1,500 times 4. Remember the commutative properties. We can do it in here. 1,500 times 4. 4 times 0 is 0. 4 times 0 is 0. 4 times 5 is 20. Write 0, put 2 up, and then 4 times 1 is 4 plus 2 is 6. So 1,500 times 4 is 6,000. Let's write the conclusion. So in a month, she buy 6,000 grams of mangoes. Next, number 12. Complete the number line. Look, we have the number 0 and 1. The difference between 0 and 1 is 1. Yeah. And then look. This divided into how many equal parts? From 0 to 1. Let's take a look by the horizontal line, or from the lying line, from 0 to 1. Okay. Oops. From 0 to 1. Let's take a look. 1 part, 2 part, 3 part, 4 part, 5 part. So it is divided into 5 equally parts. So the total parts is 5. So we need to write out of 5 here. Out of 5, out of 5, out of 5. So the first number here after 0 is 5. Yeah. After 0 is 1, and then 2, 3, and then 4. That's also 4b. Let's take a look how many parts it is divided. 1, 2, 3. There are three parts. Yeah, 3 equally parts. It is divided into 3 equally parts. So let's just write out of 3, out of 3. And then here we write 1, this is 2. And then number 13. Tina bought a pizza. The pizza is divided into 10 parts equally. Ratna took 2 slices of pizza, Debbie took 3 slices of pizza, and the rest was for Tina. Proof that Tina only got 5 out of 10 of pizza. Let's draw the picture. So we have circle pizza here. Don't forget to give the dot here. And then let's divide pizza into 5 parts first. 5 equally parts. Oh, it's not equally yet. Okay. So there are 1, 2, 3, 4, 5. And then we can divide it again, each divided by 2. We did into 2. 2, 3, 4, 5. So now we have 10 parts of pizza. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts of pizza. Yeah. And then we see here Ratna took 2 slices. Let's say this part is taken by Ratna. Up to you, yeah, which you want to shade. It is Ratna. This is Ratna. And then Devi took 3 slices. Up to you which part of pizza that Devi would take. I would take this part 1, 2, 3. So it is Devi, Devi, Devi. Okay, so the rest is belongs to Tina. Tina has 1, 2, 3, 4, 5. It's supposed to 5 slices belong to Tina. Remember, 5 slices. Yeah. Let's write Ratna's pizza fraction. Ratna's pizza fraction is Ratna is 2 got 2 got 2 slices out of 10 equally slices. Then we got 3 slices out of the total 10 slices. And then Ratna and Dewi's pizza fraction, we have Ratna is 2 out of 10. Dewi has 3 out of 10. Yeah. Look. 2 out of 10 plus 3 out of 10. It means they are in the same pizza. Dewi here. Ratna here. Oh, sorry. Ratna here. Okay. So if we combine them all together, it became 1, 2, 3, 4, 5. It's going to be 5. 5 parts out of 10. Or the fastest way is, if it is same, 10, if the bottom is same, 10 and 10, this is the fastest way. So we can put 10 here. And then the up, we can just plus them. 2 plus 3 is 5. It is Ratna and Dewi's pizza fraction. What about Tina's pizza fraction? At first, Tina have 10 out of 10. Because Tina has the whole pizza at first. Yeah. Tina has 10 slices out of 10 slices of pizza. And then subtracted by 5 out of 10. Which is 5 out of 10 is belongs to Ratna and Dewi's pizza. Yeah. 10 out of 10 minus 5 out of 10. Because the whole pizza that Tina has is taken by Ratna and Dewi's 5 out of 10. So, as we can see here, the slices belong to Tina is 1, 2, 3, 4, 5. So it is 5 out of 10 belongs to Tina. Or if we can see the fastest way here, because the bottom is same 10 and 10, we can just write 10 here. And then look at the top, we have 10 and then minus 5, it is 5. So it is proof. Yeah, Tina only got 5 out of 10 of pizza. And then number 14, at the birthday party, Elsa had 3 out of 6 of cake, and I had 1 out of 6 of cake. Olaf had 5 out of 6 of cake. So, look, the all cake here, each cake here is divided into 6 parts. How can we know that? Because they have 6 equally parts, but Elsa got 3 slices, Anna got one slice, and Olaf got 5 slices. Draw the cake from the smallest part. Who got the smallest part? It is Anna, because Anna only take 1 slice out of 6 slices of cake. It is belong to Anna. And then we have Elsa, the smaller part, and then Olaf took the biggest part. Let's draw the cake here of Anna. 3 out of 6. So let's divide the circle into 6 equally parts. Let's draw this minus and then let's draw x or times here. Yeah, 6 equally parts. Elsa also 6 equally parts. Olaf cake also divided into 6 equally parts. Okay, so for Anna, we need to shade for Anna only got one, and then Elsa got 3 slices, 1, 2, 3 slices, and then Olaf got 5 slices, 1, 2, 3, 4, 5. And then, so the fraction in order beginning with the smallest are belong to Anna. It is 1 out of 6. And then the second, Elsa, 3 out of 6. The last is Olaf, 5 out of 6. Okay, so number 15. Look at the pictures. Okay, circle the shapes that are fractions. The circles that are fractions is this, 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 and then this, and this. Why those thick? Oh, I mean this circled, yeah. Why those circled pictures are fractions? Because they have, oh, because they are divided into, uh, because they are divided into equally parts. Okay, finish. Okay, so I think that's all. Thank you for watching. Good luck and see you.